promise, but I'm looking here at purely client side rendering what, so I'm not focusing on primary backend frameworks. You won't find a Next.js on here. And I'm looking at declarative libraries. jQuery just doesn't make sense because it's like vanilla.js. Like there's no, like you can write it as infinitely. If you want to know, vanilla.js is God tier. It's above S tier. It's not even on here, but I mean, yeah. So like, yeah, jQuery is God tier as well from that perspective, right? We're just have some fun here because I actually laid them out in the order that they were released. Would you believe it that the very first declarative JavaScript framework that was released, not the most first to get popular, but released by date, was actually my buddy here, the big K, Knockout.js. At least, so I was thinking I'd just go in order, right from start to beginning. But the truth of the matter is I realized as I kind of sat and looked at this list that there are definite anchor points, right? And almost this whole chart has to be anchored around the most successful, most popular, most known JavaScript frameworks. Otherwise, you guys watching won't have a state of reference to understand what we're talking about. Yeah, there's 3 views. I mean, let's start with React because React is it's the thing that everyone probably has experience with that they can put on a state of reference. Where should I put React? What do you guys think? I have an idea where I should put React, but I want chat to help me out here. Anyone guessing where I'm going to put React? All right, we got an E. Come on, chat. I need some participation. An F. We got C. Xcan, I think it says it all. C or D. C. Yeah. Okay. B. C right in the middle. C or B. Have today. D, C, D. Yeah. B, C. Yeah. So all over the place, right? This is why we have to start with React, because without React, we don't have a frame of reference. So for me, React is a solid D tier. I think it is basically, it's not the worst we've seen. It's far from the best. It's still considered a passing grade, but barely. Let's keep on going. Okay, so now we have our frame of reference. All right. Let's go back to the beginning. Where should we put Knockout.js? If React is a D, where should we put Knockout.js? The first declarative JavaScript framework. Used signals back in the day. Because I'm a stickler to performance, surprise, 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 I see some B's going in there. B's. Knockout's actually an E. I get why you guys see. When it came to updating very specific parts of the DOM, Knockout to this day still runs circles around React. The problem with Knockout, though, was you had to create the page. You had to actually render the stuff initially. And Knockout would go through your HTML templates and find all the data bind things and then reprocess it, making it actually incredibly slow to render. So, right? Knockout was a fine-grained renderer, actually. This is actually why I'm doing this chart. Knockout, the very first framework, was a fine-grained renderer. It doesn't just have signals. It has what we're going to define as fine-grained rendering. It was the first fine-grained rendering framework. It was possibly the first declarative framework, but it actually was a fine-grained renderer, and it had signals. It just was so bad at actually rendering the HTML that Knockout was smart. If you changed a control flow, it didn't re-execute the whole tree. It did partial, it had all the aspects of fine-grained. In fact, Solid's original control flow, I learned how to write Solid control flow by looking at Knockout's internals. Knockout had pinpoint updates and modern fine-grained control flow. So It was a fine-grained render. It just was bad at rendering. So yeah, so let's go. Backbone. Backbone's a tricky one. Backbone, as described, would re-render the whole, like, people would use Backbone and then they put like almost like jQuery type enhancements. If I use pure Backbone and had it redo the templates, the thing you have to understand is this is all pre-virtual DOM. So like Knockout said, hey, put a bunch of, observable signals in there and update little things. Backbone was like, we have models and then we revalidate views, which means completely recreate them from scratch. Yeah, it's hard because part of me says that Backbone should be like E. I don't know if there's actually a considerable difference between Backbone and Knockout. It's on the fence. I'd say it's below Knockout, but is it an F tier? Thinking of the benchmarks at the time, like the spinning circles and stuff, Backbone was actually fairly good on updates. I think that's going to put in the same category as Knockout. This one's controversial, but let's keep Backbone with Knockout. These are all client-side frameworks that basically all do the exact same thing. They are literally there to update, create apps and update. This is not like something you choose because of a use case. These are almost all completely equivalent. They have special defining features, but they're all almost equivalent. Right? And we are considering legacy here because we are starting historically, right? I haven't caught up to React yet. AngularJS. AngularJS, like Angular 1, is a tricky one. It actually, and because of benchmark time, look at Hype.js, React 14 or whatever, it's actually, I'd say on average ahead of Knockout, but below React, which sticks it solidly in an E tier for me. It's close to D, but like for me, from performance and stuff, Angular 1 was never like, it was dirty checking. In a sense, you can say that Angular 1 was the first block DOM approach. We'll get to that later. But it was a dirty checking system that did a lot of unnecessary cycles and re-rendering. And those things cost more. And the last one that I'm going to talk about that came out before React is Ember. Ember was like Knockout. It had originally, Ember's over time has evolved. I probably should have more Ember on here. The only reason I won't have more Ember on here because the newer versions of Ember did not actually ever change its performance profile. Ember to this day still is in the same place, even though it's completely been rewritten in new engines and Glimmer and all this kind of stuff. Unfortunately for Ember, not everybody can be a winner. From a performance standpoint, Ember had great features. I was an Ember developer. I was a Knockout and Ember developer. Brian Florence was an Ember developer. But like, it was basically just slower at everything. Like even though it used reactivity to do like some kind of fine-grained stuff, it was still even slower doing that reactivity. And then they replaced the engine with almost something like a VDOM, and it was still the slowest VDOM. And then basically every historical line of the way, Ember has always been pretty slow. Don't get me wrong, there are frameworks on this list that are slower than Ember, and we'll get to them. But this is what the first 3 to 4 years look like. There was more frameworks, but you guys wouldn't have heard of them. I tried to pick frameworks that have like over 10,000 stars today. There's a few exceptions, but they're ones that possibly you could have heard of. Look, now this is up to 2014. We're sitting at 2014 right now. React looks pretty sweet here in 2014. We talked a little bit about each one. React, the first virtual DOM library comes out at this point, and it is significantly better, a whole category better than every other library that came out at its time. It was not the first declarative thing. It wasn't the first, like, I'm just a view. Knockout was actually has the exact same advertisement, but it was significantly better than everything up to this point, right? You'd be like, where is it? Okay, this R, I just included this one because I needed something else also from that time period, 2013, 14 time period. This is reactive. This is Rich Harris's originally reactive framework. It was used git.set and set for its like signals implementation. It's very early work in him making kind of like a knockout-esque framework. And so it is also pretty solidly E tier. But just wanted to give a quick shout out there because Rich Harris was already there pre his Svelte days. Now we're getting into 2014. What else came out in 2014? Marco, primarily a server-based framework, right? They invented islands, out-of-order streaming, basically suspense. By 2015, they had all the features that we talk about these days. But we're talking about client-side rendering. So Marco, surprisingly, I don't know if you guys know where Marco goes. Where do I see some S's and A's in there? I don't want to disappoint you all, but Marco is not for client-side rendering thing. Marco is actually, I'm going to put it D. These days, I think it's kind of slid to an E, but it's always been very close to where React is. Yeah, all right. Now we got Vue, and I'm going to count this category as Vue 1 and Vue 2. I know there was improvements over it, but is actually an interesting one. You guessing B tier? That's not a bad guess. Not a bad guess. C, I think. D tier, maybe C. Yeah. Yeah, Vue, I'm going to give it our first C tier. I don't know what about it. I think it was a slightly faster virtual DOM. They had signals under the hood to kind of make its re-rendering process a little bit better. But generally, if I go back as far as I can, Vue has been basically just a category above React. Vue always underrated. Yeah, right. So Vue is pretty good. But Vue was not the only one. Around that time, single file components started showing up. We had things like Riot. I don't know if anyone's familiar with Riot. I imagine not, but I'll help you out. Riot is also a C. You like Vue, these are new VDOM libraries that use signals essentially, or under the hood some reactivity to trigger their VDOM. In the 16 period, you guys might not know this one, Mithril. This one was like a faster, pure functional approach to the VDOM. I'm also going to put that as a C. Basically, people saw React and they're like, we can do better. Right? And they did, honestly. As time kind of went on, we start seeing things fill in. Where's Aurelia? Yeah, I don't have Aurelia. To be fair, I just realized I don't have Elm either. Yeah, this is one of the first like compile to JavaScript framework pieces. So let's get Elm in here. Because Elm might be it's hard. It's either C or it's yeah. I'm trying to think of because like I know offhand where Elm sits these days, right? It's kind of a C, maybe. But I feel like historically it might have been more of a B. So it's like Oh, it's tricky. I'm actually gonna pull up an old JS framework benchmark with Elm back in the day, just to kind of get my bearings here. Yeah, let's look at this. Elm. Because like, okay, Mithril 122, Vue 2 115. Uh yeah. Elm is 1.34. Ember is 2.14, just to give you, say, I don't know why Mithril's slow on this one. This is pre-release, yeah. Mithril's like 1.22 there, okay. Yeah, okay, that's good enough for me. I'm gonna put Elm as a solid C. Okay, so there we go, we got Elm in here. You're starting to see a trend, right? It was a VDOM like React. But again, what we're seeing here is a bunch of VDOM libraries that are slightly improved over React. So the next one on here is important. This one, honestly, I think is going to be the most controversial placement for me. Where does Inferno go? Because there's clearly a trend. You're seeing how we're kind of building up. We started in E. React showed us that D was possible. And then, Marco came in and then a bunch of these guys improved. But then out of left field, we get Inferno. And Inferno, if you go look at tests and stuff today, it's probably verging S tier. But the thing is, the funniest thing about Inferno is about 2 years ago, something changed in the browsers and Inferno suddenly got faster without the code changing. So like, it's like, should have it always been faster? Most of Inferno's life, it's been a solid A tier. Oh, why can't I drag anymore? So I'm gonna put it here for now. It's questionable, but it's it was the first framework that was like it just skipped the category. There was no B frameworks. Things that people are just kind of creeping past React to C, and Inferno's like, yeah, you guys, this space is a lot bigger than you thought. Like when React came out, people were like, oh, we've probably hit web rendering performance pinnacle, and Inferno was like, you guys aren't even halfway there. What's questionable is whether Inferno should be S tier. Yeah, power static analysis in JSX. Dominic Ganaway, way ahead of time in its approaches in terms of optimizing. He took something that looked like React and made it way faster by clever engine level optimizations and using static analysis on JSX, which would later lead him to get hired at Facebook to work on Prepacked for the React core team. And his compiler skills to come up again because he was also the lead on Svelte 5. So this is I already mentioned where Rich Harris kind of jumped in the game back with Reactive, but Dominic made quite the debut. Irrelevant for the stream. Yeah, he worked on Lexical at Facebook as well. Kind of the React core team. The tricky part with compiler analysis is you need to set some certain boundaries or rules or constraints around it. And the React core team with the concurrent model wanted to go a different way. So basically they weren't able to apply his optimizations. And he found himself kind of sitting on the React team and being like, how do I fit in? The projects are the interest stuff that they hired him for, because like he basically blew everyone away with Inferno. He found himself like not being able to actually work on React moving forward. So he picked another incredibly difficult problem, which is getting high performance in text editors, along with accessibility. So there we go. We got Inferno. All right. Next is Preact. Where do we think Preact come up? Those two came out almost, I think, a month or two apart from each other. We're right at the end of 2015 right now. No, I will not be placed. I follow benchmarks. Preact actually, from a performance standpoint, has always basically been another one of these Cs. It's a good C, but it actually, and most of its life has lived very, very close to Vue, maybe even slightly behind Vue. So Preact's going to be a C. Next one. I'm using the modern logo, but I'm only going to give Angular a second thing. It's arguable that Angular 19 forward, or the next version of Angular, like there should be another Angular at the end of the list and it should use this new logo, but I'm now doing Angular instead of Angular JS. Order doesn't matter. I'm just putting them in the order that they were released at the specific tier. So Angular 2, 3, 4, 5, whatever. D, maybe even E. Anyone else got any guesses where I should put this? I'm waiting on you. What do you got? E, D, C, S, D, C. Yeah. Angular. Angular has always, this is the weirdest thing. I don't know how they do it. Angular and React have been lockstep for basically forever. I like only recently, that's why I mentioned it. In the last year or so, I've been seeing stuff, maybe different types of control flows and stuff, like things starting to where Angular is separating itself. But no matter the release, no matter what came out, React got a little bit faster, Angular got a little faster. They basically have been lockstep for all of time. Right? Is the same at the well, the funniest thing is most frameworks actually move up at the same time. So generally actually yes. There's not enough, it's very rare that frameworks actually move more than maybe half a tier away from where they were sitting comparative to their competitors. No, this is not Angular powered by Signals. This is Angular like for the last like this is Angular 2 through I don't know 17 or whatever. Um yeah. Angular with Signals is probably a C, maybe even a B. The funny thing is Angular tends to actually always be just a tiny bit ahead of a React. It's funny because when you talk to the Angular folks, they like React. I don't pay attention to React. I don't look outside of Google, like historically. But they've always somehow managed just to be like right there or like right in front of. All right. Now we get Svelte 1 and 2. So we get Svelte 1 and 2. I'm not that familiar with Svelte 1, but so this is basically Svelte 2. Svelte 1 and 2 is any guesses? I know because I'm the one who did the upgrade from Svelte 2 to Svelte 3 in the JS Framework benchmark. But this is Svelte 2. This is before it got the updated syntax and the new compiler and all that kind of stuff. Got some C's, some B's, some D's, B or C, yeah. I'm going to say that Svelte 2, oh man, was a significant improvement over, or Svelte itself was a significant improvement over Reactive, but it is also C tier. Yeah, a little bit. The disappearing framework thing really caught on with Svelte 3. If you've never seen old Svelte 2, it looks more like Reactive. It had like single file components, but it had like .get and .set for state. There's no like let variables. Svelte 3 is a Svelte that everyone knows. This is the Svelte that now that was 2016. That was actually the end of 2000s, towards the end of 2016. This framework might have actually come out before Svelte, and I might have put it in the wrong order. But we have Inferno at A, and everyone else is kind of below it. This one here's a small framework. Blazor has a client rendering framework, to my knowledge. HTMX does not. Blazor actually has like a JavaScript framework that does rendering. This one here is a small one. This one's called Imba. It was made by like the Scrimba people. It was a compiled language, kind of like Elm concept, and they kind of called it out as like the fastest framework. They made this stupid benchmark that Rich ended up using in the Svelte 3 release, where they showed it was like 20 times faster than React. The reality is it wasn't. But if you're looking at the time and the type of frameworks that were popular and available, there were other faster frameworks. I don't have like the fastest VDOM things. They weren't that popular. Like other than like you can imagine when Inferno came out, that there's like half a dozen other smaller frameworks that work like Inferno, but nothing that kind of caught on. Imba solidly is going. Many of you probably don't know it, but it's going to be our first B. Can't drag on this computer at all because it's stupid. It's going to be our first B tier framework. It actually did have significant performance improvements over what had come before, but it wasn't quite the same. Again, it was a virtual DOM approach. It was leveraging a compiler, just not as efficiently as Inferno. Its big point of sale though was like the DX. If you ever seen it, it's like CoffeeScript almost, and they're templating like CoffeeScript. It's like this. It's completely its own language. Yeah, the marketing on Imbo was really good. I remember that. All right, so we're basically at 2016 right now, and between 2010 and 2016, we went through half the list. It was a very fast period. We went from 2013-14 with React to filling in the rest of this chart in almost no time, right? Next one I got here is HyperApp. It's got like almost 20,000 stars on GitHub. You probably don't remember. This is when libraries started, like Preact kind of started this small library thing because Preact was only 3 kilobytes. HyperAct was like, can we do it in like 1.2 kilobytes? HyperApp is performance-wise was a VDOM or whatnot. So it was small, so it loaded faster, but it is still going to be this dictionary popping up is so much fun. It's still going to be in this category, I think. That's why I feel like it. I don't know if anyone knew it. Why was Preact faster than React even before Signals? Preact always went with a slightly lighter, more optimized version of it as VDOM. Preact and React historically have been closer in performance than people give them credit for, but they've generally always just been a bit ahead. A lot of people, when Inferno came out, they assumed that Preact was like up with Inferno. Those are the two leading things, but Preact and React were a lot closer than Preact was to Inferno. Preact was created probably for size, I think. I don't know. We'd have to ask Jason Miller, but Preact was considerably smaller. React even back then was still like 30 some odd kilobytes. Preact was 3 kilobytes. Inferno split the difference around 8 or 9 kilobytes, or maybe 10 kilobytes, but Inferno was about speed. No, Preact is still a VDOM until this very day. Preact is, yeah. This is why there's a lot of misconceptions out here. I really want to clarify on some of these parts. If there was a major change like Preact stopped being a VDOM, we will get to it, and we'll have a separate category. But Preact is still here. Okay, I got one for you all. Lit. It's funny because I didn't put this out here because people start saying like their favorite web component frameworks like Shoelace or whatever. Generally speaking, web components will add a tier to your performance. So like if you're an A framework and you made the web components, actually that's not true. If you're towards the top end, like an S or an A, it'll take 2 tiers off. And then if you're like maybe like D, it'll take 1 tier off. So if you had React, you put in a web component, now you have E. If you had an S tier and you put it in a web component, now you'd have a B tier thing. So lit itself, I'm talking about the renderer. I'm not talking about the web components. Preact, yeah, no. Lit has no VDOM. It's a dirty checking system, but it and another lighter HTML, I think, or what was the original one? Hyper HTML by which actually came out before Lit and did exactly the same thing. Just as I said, not as popular, and he made like 4 different frameworks. Every time he came up with a new version, Andrea Giamacci ended up like making it different and then getting different GitHub stars, unfortunately. So like it never got popular, but Hyper HTML in the spring of 2017 pioneered a completely new type of rendering, bringing back dirty checking, but leveraging the fact of cloning templates. And more specifically, template literals, because template literals have this weird property. I don't know if you guys know with tag template literals, it remembers the static array, like the static strings that you pass to it. So if you have I can just put something in here so you can see what I'm talking about. But if you have a tag template literal like HTML, and you have a function like, let's say function my component, right? And then in here you have this, right? So you return HTML, and then you put like, I don't know, div, really care, whatever. And then you have some interpolation in here where you have like some value 5, whatever. What this gets converted into essentially like HTML function, and then it's like an array of static, and then like a list of the holes, right? And this static array is static forever. If you call this function 10 times, they don't recreate this array. They just know this array exists, which means that you can use this array as a stable reference, even if you re-render or recall this component over and over and over again. In a sense, it works like a VDOM, but it only fills in the holes by dirty checking the values in the holes. And the static array serves as a stable reference, kind of the same way that React hooks would keep references or whatever. And this is an interesting property built into the base of tag template literals, but it basically invented a whole new type of rendering back in 2017. It works like an Inferno VDOM, kind of, yeah. And so lit HTML is small, fairly small, maybe about 12 or 16 kilobytes. And it's our second A tier. Something finally joined Inferno at the top. So credit goes where credit's due, so to speak. Even if lit, with the web components and everything, ends up maybe a B to C tier, lit HTML is a brilliantly fast renderer. All flames is a pattern, right? Well, I mean, blazingly fast. This is the original blazingly fast Inferno, right? So these flame logos were a good way of showing people that you're blazingly fast. Okay, now we're getting into 2018. This one you guys might have heard of. It's called Alpine. Let's see if you can guess where it goes. It's a fine-grained rendering system, like some of the earlier ones we saw, like Knockout. It uses signals. It does not use a VDOM. And it uses template data binding, kind of like Knockout did. So when it renders the template, it has to parse through the HTML to get its bindings. It is based on Vue's reactivity package, but as people should know, reactivity performance actually doesn't impact render performance very much. Like if your reactivity package is very slow, it will, but if you take almost any modern one and swap it, your framework won't be faster. That's not true of like 5 years ago, but these days, like the optimal change between reactivity doesn't make a difference. Alpine is going to be our second one to go in the F category, actually. Alpine has fast reactivity, but its templating is slow, even slower than Knockouts. They didn't optimize things like control flows, even though it was fine-grained. It's interestingly enough, not even because of the Vue, because they got the Vue reactivity in their own stuff. It's not even particularly small. If you remember, there was a petite Vue thing Evan made over a weekend, because someone made some comment about Alpine being like a better Vue, even though they was using Vue's JS reactivity, and I think that you don't piss off Evan you, especially when it's something that like literally he could spend a couple hours, because Vue 1 was kind of like Alpine or closer to Knockout. And so essentially, it it's basically Knockout, but maybe slightly smaller than Knockout, but generally just similar approach to Knockout JS, just kind of worse. Yeah, I don't know. It's an interesting one because in some ways it's really easy to adopt Alpine for backends the same way it was easy to adopt Knockout or Backbone or some of these original tier ones for backends, which has made it popular. It's like a retro version, but in some ways it hasn't actually improved and maybe even slightly worse than the original. Like in some ways Alpine is better. They're better at handling what I call like hydration type scenarios where you're like trying to wake it up in the client than Knockout. Knockout never really considered those kind of scenarios. But on a raw performance level in the client, Alpine is yeah. See, everyone says it'd be biased, but the benchmarks don't lie. Solid, I'm gonna obviously, where am I gonna put Solid? A tier? No. Solid was the first S tier according to the modern. Did modern? The funniest thing is it kind of did, but it didn't do anything. The browsers changed. So this is why I said Inferno was the most controversial thing here, because the browser changed and now Inferno and Solid are almost next to each other. Inferno might be like slightly behind, but it was from no change on Inferno's part. The browser changed. So we've seen some compiled JS libraries. Yeah, Blazor was also came out in 2018, and we're getting into compiled languages that aren't JavaScript. Blazor, some people made a joke that Blazor could have its own category, and they're not wrong. Blazor is basically this. It's like almost feels bad putting Blazor next to Alpine and Ember because Alpine and Ember are at least a tier's worth better than Blazor. Blazor is essentially like it's hard to like if you went out and just took some JavaScript and then like JSON stringified it and then inner HTML'd it everywhere and didn't do anything you could think of optimally, it would probably be faster than Blazor. It's not Blazor's primary purpose, but it's like, yeah, I don't know. HTML is fine. It's just that. Okay, next one. First of the Rust libraries. This one was based on React. It's called U. It's a Rust framework that renders a VDOM, just like React. See, what I'm hoping you get at here, for the most part, is from this point on, we can start getting more accurate at guessing where these things go. Yeah, U spelled Y-E-W, like the tree. Any guesses for you? Did anyone even know you? Probably faster than React, but slower than. There is an overhead of doing WASM in the browser that people had to get over, and U was not the one who figured out how to do it. That being said, U was impressive because as the first Rust compiled framework, it actually did a decent job of matching its influence. So U here is, I can spread these out a little bit. U here is actually a D tier. Yeah, WASM has overhead because of the communication and the serialization boundary. So pretty cool to see Rust on it. We've got Blazor, some C#. We got Elm. We got Imba. Where's Imba here? Some different compiled languages. But I mean, Vue has almost 30,000 stars on GitHub. Okay, now we're in for a big one. One that really revolutionized the way people think. This is Svelte 3. Svelte 3 was a pretty significant jump up from Svelte 2. Not the biggest, to be fair. But Svelte 3 definitely was an improvement here. So technically, everything had been revised with the new compilation, but mechanically it was the same general idea where it was doing dirty checking that was compiler optimized. But I think Rich had moved away from, I don't know if he compiled the signals in 1 or 2, but he moved away from the like old reactivity and almost went straight to like, let's get rid of it all. Let's just use the compiler on the language. So yeah, Svelte, we got some guesses. We got B plus, B, A. Yeah, B plus is actually probably the where this Svelte 3 goes. I think it is a good B framework. It is, I'd say, slightly better than Imba for performance. We're gonna copy one of these. So we have seen over time libraries kind of start getting up there, but like in terms of a timeline, this group has been taking a little bit more to move up, right? This is 2019, right? So by the time Svelte 3 comes out, we already have Inferno, we have Lit, we have Solid. It is a sizable improvement to Svelte though. Right, and then the next one I have on my list, I guess I'm jumping right to 2020. I guess the rest of 2019 was a quiet year, which is Vue 3. Was that 2020 or 2021? It doesn't really matter. They were working on it long enough. So we're gonna put Vue 3 in. And can you guys guess where Vue 3 is? Yep. Slightly behind Svelte. A little bit slower than Svelte, but solid B tier. The interesting thing about these is going from 2 to 3, they updated their change management systems, both of these frameworks, but they didn't actually change their mechanics for rendering. This is still dirty checking. This is still a VDOM, just like this is a VDOM. Yeah, September 2020. Yeah, so I'm pretty accurate here. The F tier stands for Flutter. Flutter and Blazor can battle it out. Well, Flutter Web. I don't know if Flutter Mobile is any good, but Flutter Web is not particularly impressive. Preact equals Vue, but React at this time? No, Preact is still in the same place. Preact has not moved at this time. Preact is still solid C. 2019 to 2020, Preact is in the same place. Okay. Now we're getting to 2021. And the next framework I have on the list is Quick. Incredible non-hydrating framework, has signals, right? Of the frameworks that we have listed today at this point, the only one that has signals that was created after, I mean, it's hard to say. Vue had signals under the hood, so then Vue 3 actually still has signals plus a VDOM. Svelte has an optimized compiler. Quick is, let's see if you can guess. Quick has signals plus a VDOM. Where do all the signals plus VDOM libraries go? The difference between Vue is a weird exception because they did incredible compiler analysis, But all these signals plus VDOM libraries are actually right here. So Quick comes in as a C tier. Yeah, in terms of performance in the client, Quick was great, but not in terms of performance client, it's not outstanding. It's actually it in Preact. I think they might even have the same base on their VDOM implementation, like the same inspiration. There's a couple like, oh God, what is it called? There's a few different VDOM implementations that were created back in the 2014-15 period. Yeah. So VDOM plus signals they generally highlight really well for the single pinpoint update case, but then you're paying more on the re-render because the signals are heavier than the VDOM. So if you're re-rendering stuff, signals work against you. If you're doing pinpoint updates, signals work for you. They're kind of at odds with each other. Vue, through careful compiler analysis with Vue 3, managed to just break out of that, but they are the only one that, and I think it might be true to this day, that does signals plus VDOM above a C tier. That again makes Vue 3 Vue impressive. Okay. You guys see the line face? I got one for you. Million.js. It uses a mechanism of using a compiler to basically flatten out all the VDOM nodes into cloning, similar to the way Solid and Lit does cloning, but keeps the holes kind of like VDOM-ish. Yeah. From its description, it should be an A tier list. But from its actual score and performances in benchmarks, we've got our second S tier. Million is very fast. Aiden came out and did this whole video where he was like showing 70% fast in React. That was not accurate. Right? But Million is definitely faster than other solutions. Block DOM in general is fast because it's basically an optimal mentality of the VDOM. It's essentially a place where you've erased everything but the holes. The way that Dominic Ganaway always described to me what a VDOM was. Right? It's funny because you see Svelte 3 and Vue 3 here, but a lot of people at this time period thought Svelte 3 and Vue 3 and Solid were all the same. This is not the case. Actually, I wonder. So, yeah, I mean, it's arguable that in practice, Million might be an A tier because it still has to deal with a re-render model. Maybe if you add Million plus signals, you could do something smart there. But from a raw rendering benchmark performance standpoint, when people are clocking it, Million is about as fast as it gets. Million is actually, in those kind of tests, faster than Solid. But it also can't hide, it doesn't solve the architectural problem. So there's cases where Million would be worse. If we remove spas, do we need reactivity? No, I guess. But if you can't remove, when you say single page apps, okay, no, it basically depends what you mean by single page apps. If you need client side interactivity, you need reactivity. So I guess I'll put it that way. Well, it's still a VDOM library that depends on re-renders. So even if you render the stuff fast, it's like the exact opposite of the knockout problem. When we talked about knockout earlier, we're like, it's incredibly fast at updating the one thing, but then it sucks at rendering because it also does template processing, and whenever you switch page, it's slow. Million is incredibly fast at just rendering, but it's not as good at theoretically at doing the more granular work architecturally, because it can cause re-renders. We'll get to that. As I said, we're getting pretty close to the end of the time here on the tier list, so that we can actually get into the guts of fine-grained. I just wanted to get people thinking about the kind of terminology and things we talk about. How relevant is rendering speed in 80% case? Let's say average. I mean, it's a good question. If you're talking apps, rendering speed it can impact like the sluggishness and the feel of the apps to a certain degree, but how much hard to put into numbers when you're in a certain range here? How much of a difference is each one making? I'm not sure. I will say it makes a bigger difference than reactivity performance, but I don't know if it makes a huge difference. But again, this is mostly about talking about. I'm thinking about things architecturally and if they have the impact. But you're right. None of this could matter conceptually, but this is just where the tools sit from my perspective. Well, this is a good time to kind of bring this up, because adding signals to another system has overhead. In a sense, solid signals plus millions rendering technique is what solid is. He does the same thing, the cloning the nodes, and like I told you how Leo from Mithril's big helpers, experience and bounce ideas when I was starting. I spent a lot of time with Aiden when he was first developing Million, and you'll see a lot of solid type influence in Million. Although he also was looking at the other block DOM library, block DOM. It's actually called block DOM. So to be fair, there are other impacts on that as well. But in a sense, that the modern rendering technique is kind of that. It's just in like a rendering benchmark, you're not going to tell the difference. Like this, you'll see the signals overhead, but you won't see the lack of signals not overhead. Inferno still has a VDOM. It caches VDOM nodes, but it still has a VDOM. Browser changes have closed the gap, I think, of the overhead of doing that, where Million actually like gets rid of the static nodes, like just turns them almost into templates. It doesn't care about them, where you're still dealing with VDOM nodes with Inferno. Yeah, this has nothing to do with server-side rendering and first contentful paint. It was funny. I was reading a benchmark or some client performance choice thing where they're comparing all the client-side frameworks, and they were literally using Lighthouse. That makes no sense. Like it makes sense from the perspective of like I want to compare backend technology or whatever. But if you take this list of frameworks and then only compare on Lighthouse, like it's SSR you're testing. You're not testing the framework's render speed. Okay. Next one, Leptos. Leptos is a signals-based reactive library written in Rust. It's basically Solid.js if it was ported to Rust. The only Rust I've ever looked at was when I had Greg from Leptos on stream. It was sounded really novel, but I don't know. Yeah, every framework in this list will get 100 in a hello world, pretty much. I don't think Blazor will. It is arguable that these F tiers can't make that 100 in a hello world. Maybe that's the yeah. Yeah. Leptos, I think you guys know, there's a slight overhead. Getting pretty good at guessing. Leptos is an A. Yeah. This next one's Dioxys. It's a block DOM built in it. Yeah, Leptos is in Rust and Wasm, right? We have a few of them. We have Blazor, we have U. Leptos was huge because it actually showed that you could be fast and use Wasm. Like these ones are all in like React range, and people are like, oh, blah, blah. This is like look, if you want to write a highly interactive app where you don't care that much about maybe page load times, you can use Leptos and it will probably be smoother and outperform a React app. That's what this is basically suggesting. Dioxys is also an A, says Greg. It's weird though, because if I wasn't going to give it an A, but that's only based on the JS framework benchmark performance. Can you explain, maybe Greg? Maybe this is not fair. Maybe this is incorrect, but this is where I was going to put it. Greg says that it's an A. So should we trust Greg? I don't know. Maybe. Greg knows what he's talking about Rust more than I do. Fine. Greg, you've convinced me. It's going to be an A. It's possible for the old version. This is my list. This though, in a sense, is this. Do you know what I mean? It's solid 1,000,000, but in Rust. It's happening right here. Okay, this is React compiler. Fun one. Where does the React compiler go? Raw rendering performance. This isn't about the code you write. This is about just raw rendering performance. Yeah, I think this one's gonna be fun. For all you guys saying D, why are you saying D? Same as React, yeah. Yeah, I did give them too much of a hint. Yeah, it's a D. React compiler writes really good React code, but if you what happened to the did I crop it by accident? It lets you write really good React code, but it also doesn't really change much. Similarly, if quick a VDOM with signals is here, you can guess that preact with signals is also still a C tier. It doesn't change the quality of it. Have you noticed the go from C to B has almost requires compiler interference? Going from B to A has required dropping the VDOM for the most part to either a block DOM or a reactive thing. Inferno is just so optimized that Dominic somehow changed the math. Yeah, just kind of putting that out there. Yeah, so yes, the React compiler doesn't change anything. Yeah, benchmark code is already written in an optimized way, exactly. It just means you don't have to write the optimizations of your dev. That being said, if you look at the optimized code for frameworks that aren't called React, you'll find that or like the non-re-render frameworks, you'll find that, funnily enough, the basic code is the optimized code. It's an interesting thing that we started noticing is that the idiomatic code for Solid was the optimal code, where the idiomatic code for React was not the optimal code. It's interesting. I mean, the million JS that goes in the benchmark, people use million in React, but it's not React doing the rendering. So I don't count million as like in a sense, million maybe doesn't belong on this list because um, Aiden didn't really want to make a full framework and push it. But like, there's basically nothing in the. It's million is more like a parasite that lives in your React app. Like, there's nothing about the part that million does that is React. So we got two left. We got Svelte 5 and we got Vue Vapor. Yeah, I mean, people kind of can guess where this is. Where does Svelte 5 go? I already kind of revealed this earlier. Svelte 5 is S tier. Svelte 5 is not any slower, really. Svelte 5 and Solid are basically identical. This and it's because they are also very identical, like very close in implementation. So it's signals, it's fine-grained rendering, a lot of the stuff that we talk about today. It's, as I said, we started with reactivity and we're back here, 15 years later. Vapor, I don't know where Vapor goes because it hasn't been released. Vapor in Evan's original show was S tier. In the current benchmark, it's A tier. I'm going to be an optimist and stick Vapor up here because I trust the Vue team does good stuff and that it will get there when it gets there. But that is my completed list, I think. We can shrink this down a little bit, blow it up. But okay,